All right. Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. This is a worksheet on mixture word problems. So let's jump into number one. I'll show you how pretty much all of these problems are going to go and maybe get into a little bit of the why. So it says here we've got 2m cubed, so meters cubed, of soil containing 35% sand. So let's just stop right there. So we've got 35% sand, right? So 35% sand and 2 meters cubed of soil, right? Get my pen to mark here. There we go. So 2 meters containing 35% sand. So if we want to figure out how much sand there is, which we don't really know right now, just like because I paused, whether that's even something we need, but I'll, you know, I'll let you know that is something that we need eventually, because that's how all these problems go. You want to figure out, well, how much actual sand is in there, right? Because there could be other stuff, right? Soil could be made of a bunch of other stuff besides sand, right? Like when you think of sand, you think of like beach sand, maybe if you live relatively near a beach, maybe. I live in Florida, so we're practically surrounded by beach. Um, so that's what I think of when I think of like sand, like beach sand. But it could be like regular dirt or clay or different minerals. There's some rocks in there maybe, right? So there could be a bunch of stuff, and it's actually mostly not sand, right? It's only got a little bit of sand in there. So if we want to figure how much, well, you would just take 2 and then multiply it by 35% as a decimal, right? Try not to do any math with percents. That's usually not a good idea. So always convert it to a decimal or a fraction before you start doing math. Okay, so 2 times 0.35, that would tell me how much actual sand I have. Plus, okay, then the other part, okay, well, it's mixed, right? So that's why I'm adding, right? So it's mixed, that's why I'm adding. So 6 and 15%, we're going to do the same thing. 6 times 0.15. Okay, so that's going to tell me how much sand I have altogether. Now they want to know the sand content of the mixture. So this is going to tell me how much I have altogether. Well, I know I'm going to have altogether 8 meters cubed of sand and some sort of percent of mixture. That's really what we're solving for. They want to know the percent. They didn't say percent, which was an oversight on their part, but that's what they mean. They want percent. So let's do some math here. I'm assuming, hopefully, if your teacher is not crazy, that they will let you use a calculator. This math isn't too crazy, but if you're allowed to use a calculator, and I think most of the time these days you are allowed to use a calculator, so I'm going to use a calculator and solve these. 2 times something, not that bad, but I wanted to also add it to 6 times 0.15, so forgive me for using a calculator if you like to do everything by hand. You're more awesome than I am. So here's how you solve it. So I got 1.6 when I added all that stuff up. And then in order to solve for x, I need to divide both sides by 8. 1.6 divided by 8 is similar to 16 divided by 8. 16 divided by 8 is 2. 1.6 divided by 8 is going to be 0.2. Okay. And 0.2 as a decimal would be 20%. Now they didn't actually ask for a decimal or a percent or anything. So, I mean, I guess you could in theory say it's, 0.2 meters cubed of sand or something like that. But I don't know how helpful. I mean, actually, you wouldn't say 0.2 meters cubed because it would still be a percent. So you would just say 0.2, I guess. But usually a final answer is a percent. So that's what I would do. If the teacher is not specific, hopefully they are. If they're not, I would just write it as a percent because that's probably what they want. So just keep that in mind if your teacher is bad at asking for what they want. All right, let's move on to number 2. 9 pounds of mixed nuts. Okay, 9 pounds. And by the way, what I'm doing here is I'm circling the numbers because anytime you have any math problem ever, right? Like, what's the point of every math problem? To take the numbers and put them together and get an answer, right? I mean, isn't that every math problem? Like, no matter whether you're in like algebra or calculus. So if that's the point of every math problem, the numbers are the most important part of the problem. Now, if you want to get a little bit more fancy here, I can show you what I do to solve SAT problems. I do this little thing called marking the text. Mark the text. So step one, you circle the numbers. I've already done this part on number one, but I'm doing it on number two, and I'm going to also do some other stuff too. So underline the context. So context just means like, the couple words before and after each number that you circled. Okay, so circle the numbers, underline the context. That way you can understand how to put the numbers together. And then three is even more like how to put the numbers together, or which numbers you need to be putting together, because number three, you box the question. All right, so this is like my foolproof way of knowing exactly how to get started on a word problem. If you've ever been stuck on a word problem, this is super helpful. I've got this in another video as well. I'll probably put that in the description, but super helpful. All right, so circle the numbers, underline the context, box the question. We might do this a little bit more later on. I'm just going to kind of introduce this on number two here, though. So 9 pounds of mixed nuts containing 55% peanuts were mixed with 6 pounds of another kind of mixed nut that contain 40% peanuts. So this is really similar to number one. It's like, hey, we've got some soil. There could be all kinds of things in this soil. Maybe there's like some poop in there, because that's good for plants. So, that could be in number one. But then number two, it's like, hey, mixed nuts. Could be talking like some macadamias, or maybe like some cashews. I like cashews. If you do like trail mix and that kind of stuff, let me know what your favorite kind of nut is in the comments below. Macadamia or cashew, peanut, walnut. Walnuts are supposed to be good for your brain, I guess, because they look like brains. Is that how that works? Anyways, so circle numbers, underline the context, box the question. What do they want to know? What percent of the new mixture is peanuts? So number two is pretty much exactly like number one, right? 9 pounds containing 55% peanuts mixed with 6 pounds containing 40%. You could put 0.40, but the zero is not really necessary. So, excuse me, 0.4 is fine. And then what percent of the new mixture is peanuts? Well, the amount of mixture is 15. The percent of peanuts, we don't know. That's X. All right, so notice we set it up exactly the same way. It's the amount times the percent plus the amount times the percent equals the mixture amount times the percent. So then I'm going to break out my handy dandy calculator, turn it back on because it auto turns off. This is my older calculator. I'm using an old TI 83 Plus over here. Some old school stuff. All right, so I got 7.35 on the left-hand side here. And then we're going to divide that by 15, because I need to divide both sides by 15. And I get 49, or 0.49, I should say. But I'm going to convert that into a decimal, a percent, as 49%. And you never have to worry about units on percents, okay? So don't try to put units in there. Don't try to be like, oh, 49% pounds. That doesn't make any sense. Percents are not supposed to have units, okay? So don't do that. Your teacher's going to laugh at you and hopefully not count you off like for half credit or something if they're not mean. They won't do that, but they could, depending on who you have for your teacher this year. Okay, let's look at the next cue. And I started to do number one and number two a little bit slowly, but, as we go along, I'm going to start to pick it up a little bit, do a little bit less of the showing of the work, start to go a little bit faster through it. If you're trying to just get the answer to one that's later on, I won't be offended if you scrub through the video and get to the one that you're trying to get to. Okay, so you're always welcome to do that. And I watch all my YouTube videos at like double speed, so I'm also not offended if you do that either. Okay. 5 fluid ounces, 2% alcohol, mixed with 11 ounces, 66% alcohol. Find the concentration of the new mixture. Okay, this is nothing new, so I'm not going to spend too much time on this. I'll set it up still, but 0.02, 11.66. Yeah, I got everything. Okay, so 5 and 11 make 16, and then x. And that's pretty much it. So I'm going to go ahead and just solve it all the way here. I'm going to go ahead and multiply, add, and then divide by 16. So 5 times 0.02 plus 11 times 0.66. All of that is going to get divided by 16, and I get 0.46, which is 46%. All right, and it looks like so far 4 is going to be the same thing as well. 16, 12, 19, 4, 11. Actually, maybe a little different. It says find the cost per pound. All right, so 16 pounds of brand M cinnamon was made by combining 12 pounds of Indonesian cinnamon, which costs $19 per pound, with 4 pounds of Thai cinnamon, which costs $11 per pound. So this is pretty much the same. They just started with the mixture, and they told us the mixture. They didn't need to tell us the mixture amount, though, because it's 12 pounds and 4 pounds, which add up to 16. So 12 pounds times, all right, so combining 12 pounds of Indonesian cinnamon, which costs $19 per pound, so 19, so 12 times 19, okay, plus 4 pounds of Thai cinnamon, which costs $11 per pound. That's going to give me 16, and x, which is going to be the amount per pound of the mixture. Right? So a little different this time. We're not dealing with percents anymore. But it is going to this one is going to have units now because we're not dealing with percents anymore. So we do want to be careful there. But other than that, kind of the same. This one's a little different. 12 times 19 plus 4 times 11. 272. Divided by 16, because we need to do that on both sides. 16, 16. All right, x is going to be equal to 17. 17 what? It's not a percent, so we have to know the units. Well, it was 12 times 19, 4 times 11, 16 times x. So x is going to be the same kind of unit as the 19 and the 11. The 12, the 4, and the 16 are pounds. The 19, the 11, and the x are cost per pound, or dollars per pound. It has a dollar sign, so dollar bills. So we are going to write this as $17 per lb, or pound. Right? I don't remember actually why lb is a pound. I think it's like a Latin, like the Latin word for pound is like lb or something. I don't know, because pound doesn't have a b in it, or an l. I don't know why I thought maybe it had. I don't know, English. But anyways, if you know where pound comes from, I'd love to know. Let me know in the comments. But let's move on before I get on another tangent. Fun fact: I have ADHD. The struggle is real, y'all. There's all the numbers. Remember, the goal of the question is to put the numbers together. Context, 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 context. Find the percent of fruit juice in brand A. Okay, find the percent of fruit juice in brand A. This one looks like it's going to be a little different. Emily mixed together 9 gallons of brand A fruit drink. 9 gallons. And 8 gallons of brand B fruit drink, which contains 48% juice. Ah, so 0.48. Okay. All right. And it says find the percent of fruit juice in brand A, so that's X, brand A, right? Get multiplied by the 9. If the mixture contained 30% fruit juice. Well, if we're mixing 9 gallons and 8 gallons, first of all, you're crazy because 1 gallon of fruit juice is already a lot. Like if you're gonna buy real fruit juice, normally it doesn't even come in a gallon. It comes in like a half gallon. Like the only time I'm at the grocery store and I see a whole gallon of fruit juice, it's like that fake Sunkist stuff or whatever, where it's like less than 2% actual fruit juice or something like that. And it's like the main ingredient is like sucrose or something. Um, so first of all, this person's crazy. They're just straight crazy. Maybe it's like a business and they're concocting something for a bit. But if this is like on them, then they're crazy. But anyways, besides Emily being a crazy person, 9 plus 8 is 17. So they're gonna make 17 gallons of fruit drink. Ugh, that's gross. I don't like fruit drinks that much. But it's 30% fruit juice. Okay, so then we're just solving for x. So this one's different. It's different, but not like, crazy, crazy different. The x is over here now instead of over here. There's no x over here anymore. But that's it. I mean, everything else is the same. So let's do this. So we need to, in order to solve this, let's take this just a little bit slower. So this is going to be 3.84. 3.84. And 17 and 3, I forgot that, and I just don't feel like doing math. You ever just not feel like doing math? You know? Like, that's kind of how I feel today. I just don't feel like, I'm just not feeling the mental math, Like, sometimes you're just not feeling it. Minus 3.84. So thank goodness for calculators, right? Like, in the real world, you can use calculators all the time. They don't care. Your boss doesn't care if you use a calculator in the real world as long as you get your job done, right? Anyways. So 5.1 minus 3.84 is 1.26. I think that divides evenly-ish into 9, besides the fact that it's a decimal. Let's see. Divide by 9, and I get 0.14. All right, so remember, the goal is to find the percent of fruit juice. So that's good and bad. Good because I don't have to worry about units. Bad because I need to rewrite it as a percent. So the percent kind of is the unit. Like, if you think about it, it's sort of like its own unit. Like, it's not a unit, but it, like, kind of is, because you're, like, writing a thing after 14. Like a little symbol, which is exactly what you do when there's units. You write a little thing after the number, or before the number, if it's dollar bills. So, anyways, just kind of think of it as, like, its own unit, maybe. How many mgs? So that's, is that micrograms? No, that would be mcg. Why can I not think? Milligrams. There we go. Milligrams. I live in America. Sorry. We don't use metric. It would make way too much sense for us to use metric, but, 45%. 6. 78%. Are those the only 3 numbers? Huh. Okay. How many mgs? I'm going to just keep saying mgs because I'm going to keep forgetting what mg is, even though I just remembered earlier. How many mgs of a metal containing 45% nickel must be combined with 6 milligrams of pure nickel? Ah, well, how much percent would that be if it's pure nickel? 100, which is what I score on every math test. Just kidding. Actually, I'm not. Pure nickel to form an alloy containing 78% nickel. Okay, well, let's set this up. So, how many mgs? Well, that's x. That's what they're asking, right? So they're actually asking the thing at the very beginning, which is really weird, actually. But it's all good. Metal containing nickel. All right. So here's some context. Notice I don't take the context that seriously because I do read the question. If for harder word problems it's necessary to underline stuff, then you can. But I don't really underline as much. So how many mgs? Okay, so x. Okay, that's what we're looking for, x. Of a metal containing 45% nickel must be combined, right? So plus, mixed, combined with 6 milligrams of pure nickel, so 100% as a decimal is a 1, right? Like 100%, you move the decimal place over 2 spaces to the left, it becomes a 1. Which actually kind of makes sense if you think about it. Like, what's 100% of 5? It's 5. 100% of anything is that number, right? So it's 1, right? 100% is 1 as a decimal. To form an alloy containing 78% nickel, 0.78. That was supposed to be an 8. There we go. And okay, so this is actually really tricky because how much alloy do we have, right? Well, we have X milligrams and 6. You can't add those and get a number because we don't know what X is. But we can say literally X plus 6. Right? I mean, that was tricky, but I mean that's what it is, right? Like, so however many X is, let's say X is like 2, we add that with 6 and we get 8, right? Except we don't know what X is, so it's whatever X is plus 6. So it's X plus 6. All right? So remember, all these questions are all set up the same way so far. You have the amount times the percent, or like the other thing. Sometimes it's like dollars, pounds per dollar or whatever. In that previous question. So you have something. You have like some sort of other unit going on, but you have like an amount, and then it gets multiplied by something, plus an amount multiplied by something equals an amount multiplied by something. So it's always set up the same way. It just looks a little different each time. We don't know the amount here, but the mixture amount is X plus 6. So a little bit more complicated. This is going to be 0.45x plus 6 equals, well, we'd have to distribute. We have to distribute this 0.78 thing. 0.78x plus whatever 6 times 0.78 is. Again, I am not having a mental math day here. Sometimes I like doing mental math. I mean, I am a math nerd person after all, but today's just not one of those days. Today I'm just not feeling the mental math. 4.68. Okay. So then we're going to do some combining. We're going to need to subtract 0.45x on both sides. Let's go ahead and show the work for that. I might have to turn this into 2 videos. This is crazy. That way it doesn't take too long for the video. You know what I mean? Like, just I don't want to take too long. 0.78 minus 0.45 is 0.33. X plus 4.68. All right, then we got to do this. Subtract that on both sides, 4.68. Doesn't really matter if you line up the decimal if you're just going to type it into the calculator anyways. So that's what I'm going to do. 6 minus 4.68. If you are going to subtract decimals by hand, you have to line up the decimals. Fun fact, but, All right, so 0.33 x. That looks like that's going to like go in evenly, and when I say that, I'm using that term loosely. So don't, if you're a math teacher and you're watching this, like don't send me a comment and say like, well, actually they're decimals, so they don't go in evenly. Like, yes, I know, but I'm not here to be super technically right. I'm just here to get the answer. And it looks like the answer is 4. 4 milligrams. Let's put that mg in there. mg, boom. All right, cool. So we've got another page here. And actually, there's only 4 questions. I don't know. If this was a live video, I'd be like, what do you guys think? But it's not. So, I don't know. Let's go ahead and do it. Let's switch colors. What's a good color? How about like gold? Yeah, gold is good. All right, and let's just knock out these last 4 here. Just kind of knock them out pretty quick. And then we'll check our answers. Let me know if I got something wrong, in the comments. Because sometimes I don't check my answers when I'm doing these. But if you're going to do your homework and it's graded for completion, I would recommend checking it with the answers to make sure you got it in there. You got to make sure you have the work and the right answer. All right, so 7. Let's do this. Let's get this done. Mix with 3 liters of 15% acid solution. Acid solution. All right, find the percent concentration of the first solution. Okay, so 7 liters of an acid solution. Okay, so we don't know what the percent is of that. Mixed with 3 liters of a 15% solution to make, well, 7 and 3, so 10 liters of a 29% acid solution. All right, yeah, this one was easier than number 6. Number 6 was like way harder than this one is right now. So we just have 7x, and actually, let me go ahead and I can do multiple. Yeah, you know what? Let's just do this. Let's just do this. Let's just do all the work on the calculator. So what I'm going to do, I'll just tell you what I'm doing, and you can follow along with me here. 3 times 0.15 plus 10 times, I didn't have to do this in the calculator, but, oh, wait, hold on, not plus. I'm trying to go too fast. Okay, here's what I want to do. Parentheses, open parentheses. 10 times 0.29 minus 3 times 0.15, because I'm going to subtract 3 times 0.15 on both sides, and then I'm going to divide that by 7. All right, that would be doing it all at once. So that was a lot. That was a lot. If I lost you, let me know in the comments. I'll explain it out a little bit more. But basically, this came over here, right? So minus this. And then you figure out what that is in the calculator, whatever that is. It's 0.45. And this is 2.9. 2.9 minus 4.5, or 0.45. But yeah, 0.45. So that's 0.35. Or no, it's something else. And then you divide by 7, and you get that. So 7x equals 2.9 minus 0.45. And then whatever that is, and then you divide by 7. Right? So there's that. But just for sake of time, I'm going to go ahead and just, solve it for x, like right off the bat. So I'll set it up still, but then I'll just, like, straight up just solve it for x. So 9 gallons of a sugar solution was mixed with 6 gallons of a 90% sugar solution to make an 84% sugar solution. Find the percent concentration of the first solution. So this is asking the exact same thing as number 7. Goodness gracious. 9 gallons. 9. Come on, pencil. 9 gallons of a sugar solution, whatever that is, mixed with 6 gallons of a 90% sugar. Oh my gosh. Can you imagine? Like what if you went to the store and you bought like Coke and it was like that Pepsi Throwback? Oh my gosh. Do you guys remember Pepsi Throwback? It had so much sugar in it. It was so good. But I was like, man, this has so much sugar in it. Like, you could taste it. You could taste it. Anyways. So 9x plus 6, 90% sugar. To make an 84% sugar solution. So 9 plus 6 is 15. 84%. My goodness gracious. Like, what is going on with all this sugar? It's going to get some type 2 diabetes out of this. All right, so let's figure this out. I'll go ahead and multiply these out one by one. In case number 7 kind of threw you for a loop there. So this is 12.6. You're going to solve this number 7 exactly like number 8. So if number that 7 kind of threw you for a loop. Lo siento, pero no lo siento. You can use Google Translate on that if you need to. All right, 12.6 minus 5.4, 7.2. 9x divide by 9. X igual 7.2 divided by 9. 0.8. I could have done that in my head, but again, I told you I'm not feeling it today. Find the percent. What is the percent? Oh, hey, by the way, this was not the final answer. I forgot to not write that as the final answer. JK, LOL, 35%. Can you imagine that one kid who only watched it up to number 7 and they thought it was 0.35, and then they didn't keep watching it, and they didn't get to see me change it to 35%, and they're going to get that question wrong. All right. I don't know why I thought that was funny. All right, 0.8 is 80%, so that's the answer to that one. All right, let's knock these last two out real quick. Here we go. A what? A metallurgist, met. I think that's how you say that. I don't know. Metallurgist. They make metal. So this is Magneto. Magneto is making 12.4 pounds of an alloy containing 50% gold. Ooh. Blah 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 blah. Numbers. How much of each should he use? Okay. He needs to make 12.4 pounds of an alloy containing 50% gold. Okay, so the end product is 12.4 pounds and it's 50% gold. He's going to melt and combine one metal that's 60% gold. Okay, so one metal. And this is weird. This might be a system of equations here. One metal that's 60% plus another metal that's 40%. I'm going to put an X and a Y there. Um, hmm. How much of each should he use? Well, actually, so this could be really complicated. This could be really complicated, but this particular problem is not actually that crazy because if you think about it, 50% gold, and then he has a metal that's 60% gold and another metal that's 40% gold. As long as he doesn't care like what the other stuff is that's not gold, just equal parts, right? Like think about it, like 60% and 40%. If you put like equal parts 60 and 40, what's in between 60 and 40, right? Like 50 is. So if you do like 1 pound of 60% gold and 1 pound of 40% gold, it's going to make 2 pounds of 50% gold. Does that work? So this could have been worse because this could have been like a system of equations, which those get kind of gnarly sometimes. But actually, you just need equal parts. So you just need equal parts. So if I want to make a 12.4 pounds, then I need I need equal parts. So x, it's actually x plus x, right? Like I need the same amount of the first solution as the second solution. So that means really that I just need 6.2 pounds of each one. That could have been a lot worse. Okay, let's see if we need to do any system stuff on this next one. Okay, so brand X sells 21-ounce bags of mixed nuts. Oh, the mixed nuts again. Come on, guys, you can't do something different? Mixed nuts. I remember you guys already did this. Come on now, be more original. Product. And it's peanuts again. What is with these guys? Ugh. 35%. I don't like peanuts that much. I think my favorite is probably like those roasted, like smokehouse almond things. Those roasted almonds, with like lots of salt and whatever else they put in those things. I don't know. And like maybe like a little spicy. Those are good. I like those. Peanuts are just kind of basic. All right. Brand X sells 21-ounce bags of mixed nuts that contain 29% peanuts. Make the product combine brand A mixed brand B mixed. How much of each do they need to use? Okay, so 21-ounce bags, 29% peanuts. To make the product, they combine brand A nuts, which contain 35%. Okay, so this is X amount of 35%. 0.35. And then Y amount of 0.25. Okay, so on this one, we're not going to be able to get around it, it looks like. If you combined equal parts of the 0.35 and the 0.25, you'd get 0.3, which is close to 0.29. So, I mean, like, if we don't need to get an exact answer, we could just mix equal parts again. But we do need an exact answer, unfortunately, and calculators are a thing, so like the answer would be off by a little bit if we just assumed it was 30% peanuts. So you'd get the wrong answer. So, but let's estimate. So if we divide 21 by 2, What do we get? We get 10.5, right? I'm telling you guys, I'm super lazy today. 10.5. All right, so our answer should be, if we, it's going to be about half and half. Not quite. It's going to be a little bit more of the 0.25 in order to make 29%. But our answer should be about 10.5 for both. Now, here's the thing, right? So here's this, and you know what? Let me do this, actually. Let me erase this. So if you need to go back and grab a snapshot of that, then you can do that. But yeah, I'm going to erase this here. And let's do this. All right, so we're going to just section this off. All right, number 9 is not even there anymore. So the other equation, all right, this is how you would do this using a system. The other equation is, well, x plus y is equal to 21. Now we have a system of equations. So we could solve this using substitution or elimination. If we did substitution, which I think is most people's favorite, we would subtract x on both sides, and then that would equal that. So we'd have 0.35x plus 0.25y. Oh, hey, but y is 21 minus x, right? And if you didn't catch that, let me do this. Let's do a different color. Let's do purple. It's like the opposite. So this right here is equal to y, right? So here's y. Here's the new y. I also switched the 0.25 so it's at the beginning. That way it's better when you go to distribute. But anyways, so that's that. And then now we can solve. All right, so 21 times 0.29, 6.09. And then we have to distribute. Man, this one turned out to be super gnarly. Ugh. 0.25 times 21 is 5.25 minus 0.25x, 6.09. All right, 0.35 minus 0.25 is going to be what, 0.1? 0.1x, 5.25, 6.09. So then we're going to subtract that, 6.09. Okay, so I get 0.84, 0.1x. So if we divide by 0.1, it basically becomes 8.4. So x is 8.4. Huh, okay. And what was x again? X was the 35%? Okay, so there's 35%. Oh, and it says how much of each? How much of each? Okay, so 8.4 of the x, which is the brand A, plus y equals 21. So then it would be 21 minus 8.4, and that's 12.6. Woof. All right, that was crazy. So y is 12.6. So brand A is x. 8.4, what is it, pounds? Ounces. Ounces, okay. Ounces. Excuse me. And then brand B is going to be the other one, which is the 12.6 ounces. All right, wow, that was insane. That was way harder than the other ones. Now, I think number 6 kind of gave it a run for the money because number 6 was pretty difficult as well. But number 6 and number 10, man, that was crazy. But we got done, and we got it all here. And by the way, here's the answers. Let me know if I missed anything here. 20%, 49, 46, $17 per pound, 14%, 4 milligrams, 35%, 80%, 6.2 pounds of each, right? So we got 6, it was the same. So we just said 6.2 pounds. 8.4, 12.6, okay? And there you go, right? So there's the answers to that. Here's the work. This has been Mr. Kyle, Myers Mathematics. Oh, by the way, if you haven't gotten my awesome free guide, it's called The 5 Math Mistakes Everyone Makes and How to Avoid Them. You should totally get it. It's awesome. It'll help you to not miss math problems anymore. It's on my website, myersmathematics.com. I'll see you guys in another episode mucho soon.